has a social aspect and a governance aspect. So, for example, if we look into subsidies, I mean, we know in China the use of electric vehicles has been subsidized, and as far as I
Hello everyone, welcome to the Actionable ESG Talk series brought to you by AKFI Actionable Knowledge Foundational Institute, the world's first nonprofit industry association committed to bridging the gap between ESG, sustainability, and digital transformation. My name is Isabella. I'm the co-host here with Manuel, another co-host on this show, and our special guest today, Dr. Taiber. Hello, Dr. Taiber.
Hi, nice to see you.
Very nice to see you too. Thanks so much for taking the time. Dr. Taiber is the Managing Director, International Operations of the International Alliance for Mobility Testing and Standardization, IAMTS, since 2021. IAMTS is a membership-based consortium established back in 2019 through SAE-ITC. I'm not familiar with that, but we'll make sure to type that in the description to many of our non-technical audience, just like me. And to start our conversation today, Dr. Taiber, what are your insights on the current state of the ESG and sustainability trends and how they are impacting the mobility industry?
So at the moment, I think that the automotive industry in particular is very focused on the reduction of tailpipe emissions. And this is also why you see at the moment that the car industry is very focused in the introduction of full electric vehicles. And there are basically different speeds of development. So the most progress in introduction of electric vehicles is in China, and they call it new energy vehicle. And this is quite significant because also China is the largest automotive market, and they are also the largest producers of CO2. So for their shifting from ICE vehicles to electric vehicles is very significant, also from a global perspective. And then you have Europe that is also shifting more and more towards electric vehicles, and then lagging in the process of market penetration of electric vehicles is the North American market. But in general, moving from ICE vehicles to electric vehicles to reduce tailpipe emissions is the key topic and the key undertaking that is going on in the automotive mobility industry, and it's locking up a lot of R&D resources and also triggers a lot of supply chain changes. What is obviously important to note is that in an ICE vehicle, the most expensive component is the engine. And in an electric vehicle, the most expensive component is the battery. So that means that at the moment, what you will see in the supply chain is that a lot of the automotive companies are focusing also on battery production and sourcing raw materials that are needed for the battery production. The difficult piece here is that you want to use raw materials that are plentiful, available worldwide, and where mining does not cause significant environmental damage. So that's a challenge. So there are a lot of efforts to avoid rare rare materials in the battery design. So that's underway. There's also a lot of pressure on the automotive companies and suppliers to use renewable energy to power the production facilities. So that's also a major goal. Basically reducing the carbon emission use in the vehicle itself. That would be scope 1, and then reducing carbon use in production facilities, that's scope 2. But then another element that is at the moment challenging is that there's a lot of carbon being used in providing the road infrastructure because of the asphalt being built. So another aspect that I think is important is the use of power for the EV charging infrastructure, because ideally you should use renewable energy sources for the power. And another challenge at the moment is that you have potentially close to 1 billion cars on the road worldwide. And those vehicles, most of these vehicles are still ICE vehicles, and it will take many, many years until you replace them by emission-free vehicles. So one of the efforts that the car industry is undertaking is to try to generate synthetic fuel produced with help of renewable energy sources. But here the challenge is providing the right quantity of production and also to be price competitive to fossil fuels, and that's still a major hurdle. And then maybe another element is the reduction of non-tailpipe emissions, like, for example, tire emissions. So this is a new trend, and we think the EU is already starting to regulate non-tailpipe emissions. And I think what another element from an ESG perspective, I talk now predominantly about emissions, is the affordability of sustainable mobility solutions to population segments that maybe cannot afford a new car. Or people that are using public transportation. So you want to make sure that using sustainable mobility solutions is not just a privilege for very wealthy people, but it is basically open to use for wide portions of the population. And another interesting aspect, I think, maybe more from a governance perspective, is to what degree we want to measure the sustainable mobility behavior of citizens. So for example, if you are using a 3-ton zero-emission SUV alone and drive in traffic, this is maybe not the most efficient and environmental friendly way to go from A to B, even if it's a zero-emission vehicle. So we need to consider, are we controlling our citizens in their choice of which sustainable mobility service they use, how often do they use it, and what is actually their sustainability behavior in terms of mobility. So that's another key question. So I hope I covered several aspects of ESG, and maybe we can further discuss this.
Absolutely. And maybe just to highlight the contrast between the internal combustion engines, ICE, right, in short term, It's not a black and white kind of, the EVs are sustainable 100% and the ICEs are not sustainable 100%. You mentioned the batteries, for instance, which are still using rare metals and require extensive mining. You mentioned also the roads, which are important. And definitely mentioned the supply chain, and we working at the AKFI actually trying to determine the complexity of the supply chains as the customers, the end of the supply chain, in this case, the car manufacturers, need to work, for instance, with tire manufacturers. You mentioned scope 1 and scope 2, but scope 3 is coming from the manufacturers in the supply chain. And this is probably a big component in electronics that can reach 80-90%, I don't know, in carbon.
I mean, one element that is important is consumer adoption, and this has a social aspect and a governance aspect. So, for example, if we look into subsidies, I mean, we know in China the use of electric vehicles has been subsidized, and as far as I know, is that big cities, think like Beijing, for example, they have a policy: if you are buying an electric vehicle, it's easier to get a number plate than if you buy a non-electric vehicle. So there are certain governance aspects that impact customer adoption. But it is also, for example, the price of fuel. So if it's much cheaper to operate an electric vehicle compared to a fossil fuel or ICE vehicle powered by fossil fuel, that is also pushing the customers towards more electric vehicle use. If oil prices are low, that pressure is not that big. If oil prices are high, it's different. Another aspect is the range anxiety. So there's more and more cars now that have ranges over 300 miles. There is more and more charging infrastructure solutions where you can recharge the vehicle in less than 30 minutes. So I think we need to keep an eye on what drives the customer adoption. So that is to a large degree an economic question, not just an environmental question. So shifting towards zero-emission vehicles is something that also has huge economic relevance, right? So for the consumer. So is it really is it as convenient to use? Is the EV as convenient to use as the ICE? And is it from a cost perspective on par? And then the hybrid vehicles are obviously something in between. The question is whether we see a shift from ICE to hybrid, and then a major adoption of EVs. That's the key question, and it's also the key bet of some companies. The problem is if customer adoption does not follow as quickly as the industry makes the investment, then they are not getting their returns on investment quick enough, and that brings then a lot of companies in trouble.
And you pointed very clearly to the total cost of ownership versus the sticker price. And if I look, I live in Texas, so if I look around, TCO is not a factor when you buy, a large SUV, and as you said, you are alone in the SUV. Clearly, the mileage is not there for ICEs. But I wanted to, for our the people that are watching us, and I think one question is IAMTS, right? I'm not sure if people are familiar. Maybe you can give us a quick introduction and how it plays on because I understand it's an international organization.
Yes.
It's connected to really all the major manufacturers. And, supply chain.
So to give you a little bit background on IAMTS, so IAMTS stands for International Alliance for Mobility Testing and Standardization. So very long word. So international means it's the association. It's an association, so it's a non-profit association, and it's headquartered in Vienna, in Austria. And it was originally started and founded in the US. Through the Society of Automotive Engineers, and it has been then transferred from an SAE program into an independent association. So international means the alliance is active in all key markets. Mobility means that we are working predominantly on ground transport, in particular in ground transportation. Cars, trucks, things that move on the ground. Testing, we are looking in particular in testing highly and fully automated vehicles. And standardization is that we are looking into how do we standardize test procedures, and how do we standardize type approval methods to get these vehicles into regulatory compliance. So a little bit background, when maybe around 2016, 2017, there was a lot of discussion in the world already on how quickly do autonomous vehicles come to the market. And as we all know, when you're transferring the control over a vehicle from a human operator to a machine operator, this has large implications. So on the one hand, you need a lot of intelligence in the vehicle that could then replace basically the human decision making and sensor capabilities. It also means that the liability shifts from the owner of the vehicle, human owner to the vehicle, to the operator of the vehicle, which is typically the OEM or a fleet operator. So there are legal consequences. And there's also a lot of questions. How intensively do you test an automated vehicle? And what does it take for a regulator to accept an automated vehicle to be used on the road? And so there were these questions that I just described came up a number of years back. We were those that were involved in these topics, and I was, through my work at BMW and Clemson University, quite involved in these topics previously. Before I worked for the association, so there were a lot of experts that trying to find out what is the technology needs, which standards do we need, how do we test, how do we interact with the regulator. So all these questions are being basically addressed by IAMTS. So we are several hundred experts that are being linked through this association to have a dialogue. So far, we have produced best practice reports where we are trying to share knowledge that hopefully can be useful for developers of automated driving systems, but also operators of automated driving systems to be considered. And we are influencing standardization organizations and regulators with our thoughts and with our inputs. And so it's not a lobbying organization. It's more like a technology organization that makes concrete suggestions of how do you develop the technology? How do you bring it into regulatory compliance? And what regulatory rules do you actually need? So that's hopefully giving you a little bit background about it.
Thank you. Yes, and I'll bring the question of AI, and I know that Isabella and I share an interest in AI. Actually, Isabella is looking at the future of AI and how to serve the human race.
Yeah,
A year ago.
When we talk about the future of AI, so artificial intelligence, I'm always a little bit cautious in let's say the term artificial intelligence, because if you may have heard about rule-based systems, so I can program a system to react in a very deterministic way to specific inputs. And I wouldn't necessarily say that then that system is very intelligent. It just follows rules, right? So an intelligent reasoning requires also kind of independent decision making. And so therefore the question is obviously how, in particular, if you program a vehicle with algorithms or you expose it to algorithms, what is the boundary between just following rules and maybe assessing a situation, making a decision, and the decision might be wrong, right? So if we are if a wrong decision leads to an accident and a person is being killed or a person is being injured, then it immediately goes back to the liability question. And when we deal with a human being, we always say a human being can make errors, he can make mistakes. But typically we expect from a machine that it cannot make mistakes. It actually performs flawlessly. So the problem is that there are so many situations that could happen in the real world, in the traffic, that it is basically nearly impossible to teach every single situation in every variant to a technical system. So we have some randomization of the behavior with the risk that there could be a wrong decision. And that is actually the challenge we have to take, and that has I think there are benefits to relieving a human driver from the driving tasks, but there's also challenges. How do we deal with technical failures or misjudgment of a technical system?
You pointed very clearly, and I'll turn to Isabella shortly if she has a question, but you pointed very clearly that the acceptance level for machines is not the same as humans. I think we reach already a stage where machines are better than humans at driving cars in most conditions. They are not perfect.
Yeah,
However,
and I think the emotional aspect. So I want to bring an emotional aspect in. So let's assume somebody is driving and had a bad day and is aggressive and does not keep the speed limit, does not keep a safe distance. So that's reality. So this happens every day, and the point is, if I am telling you as a driver, you are not allowed to do this, So I program the car that you cannot go over the speed limit. I program the car that if you should not make a lane change, I do not allow you to make a lane change. It will be interpreted by a lot of people as an intrusion in their freedom of choice. So if we allow people to violate rules, which happens every day on the road, is this acceptable? So if we tell them you cannot violate any rule, you cannot be 1 kilometer per hour too fast, would that work? Now with the machines, it's absolutely zero problem. So machines can be trained and can be programmed that way, but a human does not work that way, and that is also a challenge. As long as we have human drivers in the mix with the machine-operated vehicles, we have to deal with unpredictability behavior, and we need to know how to respond in a responsible way.
Very, very interesting. And I don't know if Isabella, taking a look at the future of AI, before we go there, there were reports on self-driving cars recently, GM and Tesla, right? So, we did not reach the point. But please, Isabella.
Yeah, thanks for all these great points, Dr. Taiber. Regarding, I hear a lot of ethical points in terms of how to determine the situation, and this has been an old topic, but never, gets really to the roots of solving it because of this emotional aspect of human beings, and technology at the end, it's a rational tool. And I think it's meeting in between of how to balance these two elements. It's very crucial. And a lot of things you mentioned, I hear that human factor, it's irreplaceable, at least at the moment. And I see it in a very far foreseeable period, the human critical thinking, independent decision-making process. And then there's a very interesting example here in Beijing, and a lot of automated vehicle is running already in a less, condensed area for food deliveries. And I see a lot at the conjunctions, the traffic lights, it got confused. So it will cause huge conjunction traffic problem. And the cars were stuck in there, doesn't know where to move because there's people and different cars from different direction all across the road. So it's kind of funny, but it reflects a lot of what you just mentioned. Like it's far from where we can just rely on an automated, vehicle to relieve human beings. And on the other side is the technical part. Noel mentioned the Tesla. They just recalled almost all the US, you all probably saw vehicle because of the autopilot issue.
Yes,
so,
yes.
Very,
Well, so to coming to the ethical topic, and I also wanted to maybe make some comments about how we could improve, right? So I give you and maybe an interesting aspect from the case we know from San Francisco, where a GM Cruise vehicle, there were several incidents, and one of the incidents was that a GM Cruise vehicle crashed into a first responder vehicle.